In previous videos, we saw that the change in potential energy is equal to the negative of the work done by a conservative force. And in one dimension, this can be written as follows. So differentiating both sides, the second term on the left drops out, and the derivative of the integral is the integrand. So therefore we have a relationship between the conservative force and the potential energy function. So recall for this spring mass system, we had the change in elastic potential energy was equal to the following expression. And if we take our reference point at the undeformed position of the spring, so x0 is 0, and therefore at the equilibrium position of the spring has no stored potential energy. So therefore we get the following potential energy function. And from this relationship, we can see that the force in the spring is the negative of the slope of the tangent to the potential energy curve. So what we get by differentiating this function is minus k multiplied by x. So when x is positive, the spring is in tension and the force points to the left. And when x is negative, the spring is being compressed and the force points to the right. So the force in the spring is a restoring force that brings the mass back to the equilibrium position. And note that the force in a nonlinear spring can also be a conservative force, where the force only depends on the position of the mass.